Okay, this will be my quiz solutions for quiz 7. This will be basically the first part right after the midterm. And this will be Tuesday, Dr. Holly section. Here we go. So this will be a quiz on Z transforms, and it would say determine the zeros and poles of H of Z, draw the pole zero plot. And how you do these is you basically you want to get rid of all the Z negative ones. So it's actually important too, and maybe you'll see why. So I'm going to multiply here by Z squared over Z squared. And what this will simplify to will be H of Z equals Z minus e to the j 3 pi over 4 times Z minus e to the negative j 3 pi over 4 over Z times Z minus 0.5. And the reason why I say it's important because if you didn't do this, then you wouldn't get this actual pole in the denominator, the trivial pole at the origin. So your zeros are going to be where the numerator is equal to 0. So Z equals e to the j 3 pi over 4, e to the negative j 3 pi over 4, and your poles are going to be at, let's say, Z equals 0 and 0.5. So to draw this, the zero is at 3 pi over 4, negative 3 pi over 4, and the poles at the origin and 0.5. That's this question. Next question says determine the impulse response to the LTI system. So what you need to do is simplify H of Z in a way that you can take it in for inverse Z transform. It'll give you some properties, but I'll just work it out directly. So I'm going to say, okay, I'm going to take H of Z, and I am going to just multiply it through and see how it's going to simplify. And that's basically what this property is actually saying anyway. So if I multiply H of Z across the numerator, I'm going to get 1 minus e to the negative j 3 pi over 4, Z to the negative 1, plus minus actually minus e to the j 3 pi over 4, Z to the negative 1. And when I multiply these two together, you'll just get that they're 1. So I'm just going to get plus Z to the negative 2. And the denominator is fixed. So 1 minus 0.5 Z to the negative 1. And if you realize how these exponential terms appear, then you can actually realize that this is actually the same as saying 1 minus 2 cosine of 3 pi over 4 Z to the negative 1 plus Z to the negative 2 over 1 minus 0.5 Z to the negative 1. At this point, you can say, negative 2 cosine 3 pi over 4, that's actually the same as saying that's 1 plus square root of 2 Z to the negative 1 plus Z to the negative 2, because cosine 3 pi over 4, it's negative square root of 2 over 2 over 1 minus 0.5 Z to the negative 1. And if I just break it apart just piece by piece, just to see how the inverse Z transform work out, that's obviously just 1 over 1 minus 0.5 Z to the negative 1 plus square root of 2 Z to the negative 1 over 1 minus 0.5 Z to the negative 1 plus Z to the negative 2 over 1 minus 0.5 Z to the negative 1. And the point I want to get across here is that these Z to the negative 1, Z to the negative 2 are actually time delay properties. So it'll just delay the shift, delay the original H as an impulse response by an index. So this first term here, when I take its inverse Z transform, H of n, I'm going to get that it's using this property here. It's actually for A equals 1/2, it'll be 1/2 to the n U of n plus square root of 2 this z to negative 1 induces a shift by n minus 1. So you'll get 1 square root of 2, 1/2 to the n minus 1, u of n minus 1, plus this one here, this last term is a shift by 2. So it'd be 1/2 to the n minus 2, u of n minus 2. And that would be your solution. If I can box that in. Alrighty, next question. List which normalized frequencies of omega hat will this remove? So obviously those are just the zeros. So that's 3 pi over 4 and negative 3 pi over 4. So there's your answer. Next, consider two causal LTI systems with their impulse responses. They are cascades together to form a new system. Determine the transfer function agency of the cascade system. So when we speak of cascades, what you need to know is h of z is equivalent to h of 1 of z times h2 of z. That's basically what this last property is saying. When you cascade it in the z transform, it's just their multiplication. So what you need to do is solve for h1 of z, h2 of z, and just multiply together. So if I want to write h1 of z, using this property, this first property, a is equal to -2, but it also has a time delay of 3. So that's equivalent to saying z cubed over 1 minus plus 2z to the -1. Is that correct? Yeah. Okay. And h2 of z equals 1 plus, if you're familiar with z transforms, you can look in the table if you want. 1 plus z to the -4, where on here I use the shifting property. So their product is obviously h of z equals z cubed over 1 plus z, or z cubed times 1 plus z to the -4 over 1 plus 2z to the -1. At this moment, it will be related to this next problem here, but if you want to sketch the pole zero plot, it might be useful to multiply this by some factor of z. I know here that I only need to multiply by 1 extra z, because this is z to the -4 and I have z cubed. So to make this z to the 4th, I need 1 extra factor of z. So that would be z to the 4th times 1 plus z to the -4 over z plus 2. And that's equivalent to z to the 4th plus 1 over z plus 2. So you could have stopped your answer here if you wanted on the previous question, but I am aware that this next pole zero plot, just by how you think about it, I always need to make sure that there are no z -1s whenever I sketch the pole zero plot. So this is a little bit more useful for this. And so first of all, the obvious pole is that z equals -2. The zeros, however you want to think about it, this makes sense in your mind, but they're going to be located at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I'll just write it as e to the j pi over 4, e to the 3 pi over 4. I'll write 5 pi over 4 as and -7 pi over 4 as e to the -j pi over 4, and e to the -j 3 pi over 4. Those are my zeros, and my poles as z equals -2. The last part is saying determine the output y of n of the cascade system for input x of n with z transform this. So what you need to know here is that y of z is equal to, and in the z domain, it's equal to h of z times x of z. So this is already fit into a nice form if you really think about it. You actually probably shouldn't use the simplified form that you have here. You actually just want to go near to the beginning of what you kind of had. So the reason for this is because if you get z cubed times 1 plus z to the negative 4 over 1 plus 2z to the negative 1. Multiply this by z to the negative 3 over 1 plus z to the negative 4. The question is well built to just let everything cancel. So this cancels, this cancels, cancels, cancels. And you're just left with 1 over 1 plus 2z to the negative 1. Since it's asking for y of n, then you need to take the inverse Z transform. So you get y of n equals negative 2 to the n. Let's say you want to use this formula, if you think of that as a formula. And negative 2 to the n u of n. And that would be your final answer. And that'll be all. So let me stop screen sharing.